All right, you guys, 13.5 is the last section of chapter 13. We're going to be looking at solving trig equations. And just to kind of give you an idea of what we're looking for, we've been graphing sine waves, cosine wave, tangent cycles. So kind of give you a picture or visual. If we have a sine wave here graphed and I'm looking for maybe where sine of theta equals 1/2. Well, 1/2 on my graph corresponds to all of these intersections in my sine wave, and that's where y equals 1/2. Okay, so essentially what we're looking for are where all these solutions occur on our graph. Some of these aren't going to be as simple as, where is sine 1/2? We're going to have more complex equations, but we're looking for the solutions to those. And a lot of times we're going to be looking in one rotation of the unit circle from 0 to 2 pi. Okay, so we're going to go through a few strategies here as far as solving, and then hopefully we'll send you on your way. So first thing, looking at our equation, I notice it is equal to 0. And I notice that both terms have a cosine factor in them. So our first strategy is factor if you can. Okay, since they both have a cosine, I can, do the reverse distributive property. It's called factoring. So if I factor out cosine, I wind up with sine of theta minus 1 equals 0. And just like back in chapter 5, once we're in factored form, we're going to set each portion of that equal to 0. Because we know if cosine of theta equals 0, our equation equals 0. If sine of theta minus 1 equals 0, our equation has to equal 0. So once you're at this stage, you'll just want to simplify down and isolate your trig ratio as best you can. So if you notice, we have two things we want to solve for. So we have cosine of theta equals 0, and we have sine of theta equals 1. This is where you're going to want to go to your unit circle, and you're going to want to figure out where is cosine, or where is my x value 0? Well, if you remember back to chapter 12 and in 13, cosine of theta is 0 at pi halves and 3 pi halves. Notice we're using radian measure, not degrees. Typically moving forward in pre-calc and calc, radians is going to be much more the focus. So you're going to see us do a lot of work with radians rather than degrees. Moving on to the second portion of our answer, looking where sine of theta is 1. So I go to my unit circle, I'm looking for where is my y value 1 on the unit circle? Well, at pi halves. So those are my solutions. I factored the initial equation. I set each portion equal to 0, and I solved, just like we did back in chapter 5, except now we're using our trig ratios. Part B, very similar question, except I can't factor right away. If you notice, these are two different trig functions. I can't put them together. So sometimes before we factor, we might need to use a trig identity, okay? And I know that sine of 2 theta equals 2 sine theta cosine theta. That's on my helpful hint sheet. So now I have this equation. They're equivalent. They're the same thing. If I want to factor, my equation has to equal 0. So I'm going to move cosine of theta over to the left. And now I can factor out cosine. So I wind up with 2 sine theta minus 1. And then I have a factored product. So I set each portion equal to 0. Some of you can jump ahead. And if I set this 2 sine theta minus 1 equal to 0, if I add 1 divided by 2, I know that sine must be 1/2. Once you have your trig ratios isolated, you guys can go right to the unit circle. I know cosine of theta is 0 at pi halves and 3 pi halves. I know sine of theta is 1/2. Keep in mind our y value is sine, so I'm looking for where Is my y coordinate 1/2? Well, that's true at pi over 6 and pi, or 5 pi over 6. So those are the first questions. Look for factoring, look for trig identities, and then factoring from there on these more complex problems. All right, continuing on. Second example is looking at a Ferris wheel and looking at your height, or what time your height is, 41 meters above the ground. So in this instance, we know 41 is our height, and we are looking for our time. So I'm just going to plug that information in, and now it's just a matter of solving. Whenever we're solving trig equations, again, the goal is to isolate my trig function. So I'm going to subtract 21 and divide by negative 20. 41 minus 21 is 20. 20 divided by negative 20 is negative 1. So we wind up with negative 1 equals cosine of 3 pi t. Okay? At this stage, what I'm going to do is I'm going to jump to the unit circle because I know cosine of theta is negative 1 at pi. Okay? So that's kind of the key piece I'm going to keep in mind. So when my angle is theta, I know this equation is going to equal negative 1. Well, that means I need to take my angle and set it equal to pi. And then we just have to solve. If we notice, there's pi on each side, so I'm going to be left with 3t equals 1. So I know t is 1/3. And if you look at the label, it's 1/3 a minute. You can always switch it over to seconds. So after 20 seconds of your ride, you will be 41 meters off the ground. Continuing where we're squaring both sides of we have a few more complex problems, or more complex. So we're going to go through a few different strategies here. On example 3a, you want to think back to chapter 5. So if I had 2x squared minus 3x minus 2, how does that factor? Because it's going to factor the same way we would in this case, except x is cosine of theta. So if we're thinking 2x squared minus 3x minus 2, I'm thinking, what are the factors of negative 4 that add up to negative 3x? So negative 4 and 1 give me negative 3x. So I'm going to factor by grouping. In the first group, I can take out a 2x, and I wind up with x minus 2. In my second group, all I can take out is a 1, and I wind up with x minus 2. So I get 2x plus 1 and x minus 2. This is exactly the factoring we did back in chapter 4 and 5 as far as things go with polynomial equations. Okay, so we just did factoring by grouping. Again, we looked for factors of negative 4 that added up to negative 3, split them into two groups, factored those groups separately, and then we wound up with this product. When we're doing this, it's important to keep in mind that x was actually cosine of theta. So I'm going to shift up a little bit here. So as we're solving, we actually have 2 cosine theta plus 1. And then we have cosine of theta minus 2 is what it works out to be. So our two answers, we have cosine of theta is negative 1/2, and we have cosine of theta equals 2. Well, some of you are probably eyeing this up right now, and you're like, there is no x value on my unit circle that is ever 2. You are, in fact, correct. So there's no answers to worry about there. The only answers we have to worry about is where cosine is negative 1/2, and that's at 2 pi thirds and 4 pi thirds. So that's how we get our answers in that case. Again, there was no identities to use. We had cosines in the problem. All we had to do was factor and then, refer to the unit circle to come up with our solutions. There's going to be some instances where we have two different trig functions and there's no identities that actually work. Okay? So if you look at your formula sheet, all the Pythagorean identities are for cosine and sine squared. So in this case, neither of those are actually going to work. So a strategy, if you can't factor and you can't use your identities, what you're going to do is you're going to square both sides of your equation. Because now at this point, on the left, we have cosine squared theta. On the right, we're going to have 1 plus sine squared, which works out to be 1 plus 2 sine theta plus sine squared theta. Okay? Then, now we go through that process again. I know cosine squared is 1 minus sine squared. And then our right side stays the same. Then from here, if we do want to factor, our equation has to equal 0. The 1's cancel out. We wind up with 2 sine theta. And then if I bring the sine squared over, I'm going to have 2 sine squared thetas as well. We can ignore the 2 if we divide everything by 2. And then we want to factor out a sine of theta plus 1. So we wind up with sine of theta equals 0. We wind up with sine of theta equals negative 1. We want to figure out where those values are on the unit circle. So where's my y value 0? Well, at 0 and pi, where's my y value negative 1? 3 pi halves. At this point, whenever you guys use this strategy where we're squaring both sides of the equation, okay, super important to check your answers. So for the sake of time, I will tell you that 0 does work out in the original equation when we check. 3 pi halves does also work in the original equation. Again, those are values you could use your unit circle for. So cosine of 0 is 1, sine of 0 is 0, so 1 equals 1. That does check off. Pi, when you plug in pi, cosine of pi is negative 1, sine at pi is 0, negative 1 does not equal 1. That's why that value does not check. Same kind of rationale with 3 pi halves, it does work out in the end. Moving on to our last example, there's going to be some situations where you're actually looking for a general solution. A general solution is for all values. So thinking back to our initial problem, where we have a sine wave that goes on forever, a lot of times we were looking for solutions between 0 and 2 pi, or 1 rotation around the unit circle. In most cases, 1 cycle of your graph, okay? But if I'm looking for all values, I don't want just those 2 answers. I want every one of those answers. So what we're going to do is we're going to do everything the exact same, but we're going to modify. Whenever we have sine and cosine, remember those graphs cycle every 2 pi. So what you're going to tack onto your answer is a 2 pi k. And the reason is our answers are going to cycle every 2 pi. Okay? If we're working with tangent, we're going to want to add pi k. If you remember from graphing tangent functions, those cycles are every pi radians. All right? So let's dive into this problem. It looks like we can't factor right away because we are dealing with 2 different trig functions. So let's use our identities to get started. So secant squared, if I look at my Pythagorean identities, is 1 plus tangent squared. Then what we want to do is distribute the 2 tangent to the 4th theta. And then if we want to factor, we want to make sure to get everything over on one side. So we have 3 plus 2 tangent squared minus tangent to the 4th theta. You're going to want to factor this just like we did back in chapter 5. So we have essentially 3 plus 2x minus x squared is kind of what we're looking at, okay? So when we do factor this out, you're going to wind up with 3 minus x and 1 plus x for the sake of time. I'm trying to save you a little bit there. Keep in mind in this problem, our x value is actually tangent squared. So our first, we have 3 tangent squared theta. In our second part of our solution, we have a 1 plus tangent squared. When we solve, we get tangent squared equals 3 square root both sides. We wind up with plus or minus square root of 3 in this case. Sorry, that square shouldn't be there. On this next one, we have tangent squared equals negative 1. Well, we can't square root negative numbers, so we know that's not going to work. So the only solutions we actually need to look for are where is tangent plus or minus square root of 3. And if you think about that, tangent's positive and negative in quadrants 1, 2, 3, and 4. So my solutions are going to be pi thirds, and it's going to cycle every pi. We use the k to denote how many rotations around the unit circle you're going. This solution, this first solution, covers answers in quadrants 1 and 3. Then I need to worry about my answers in quadrants 2 and 4. So my next angle where tangent is root 3 or negative root 3 rather, it's at 2 pi thirds. And again, we're going to cycle that answer every pi k in this case. So again, as we're going through things, goals, you want to factor if you can. If you have different trig functions, you're going to want to use your identities, get it to a point you can factor. Then what you want to do, once you use those, you want to refer to the unit circle, where the angles or at which angles those values occur. If you can't factor and you can't use your identities, you're probably going to want to get the trig identities on separate sides, like example 3b, and solve from there. So a lot going on today. Refer to the discussion board. Join me for the live sessions if you have questions. Again, this is one of 3 assignments this week, so really take heed of things. And let me know if you have questions. Spend some good quality time, and hopefully these last 3 weeks will go well.